Today we're going to be talking about another aspect of the distributive property, which is factoring. The standard that I'm required to teach you involves combining like terms, performing the distributive property, and also factoring and expanding. We did some expanding yesterday and we're going to be practicing that some more, but we need to talk about factoring. So this is the title of your notebook entry. Sorry that took so long. So today we're going to be talking about factoring. Our standard says, the standard that the state says I need to teach you in 7th grade says that we have to know how to combine like terms, simplify expressions, know the distributive property and how it works, and also be able to factor and expand. We expanded some yesterday and we will continue to practice that also, but we also need to see the factoring aspect of the distributive property, which is just backwards distributive property. So we're going to call this factoring. And we're just going to put backwards distributive property. So it is backwards. So we know that the distributive property looks like this. It looks like 2 times 6x plus 5. Okay? So if we're going to do that backwards, that means that if we had this already in a simplified form, we could take it out of that and back to this form. What do you mean by that? Well, 2 times 6x is 12x, and 2 times 5 is 10. So if I were given this, I know that this is equivalent to this because 2 times 6x is 12x and 2 times 5 is 10. So this is an equivalent expression, which is also talked about in the standard that I have to teach you. So backwards distributive property is called factoring. So I could look at this 12 and look at this 10 and say, what factor do they have in common? So I could see that they're both even. So I would know that I could factor out the 2. So I would say 12 divided by 2 and 10 divided by 2. And that would give me, I should have put 12x here, 6x and 5, positive 5. And what did I factor out? I factored out the 2. So, do you see how I got this? And then I got the equivalent expression just simplified as 12x plus 10. And then I could take it back to this. It seems like clear as mud. Well, let's just keep going. Okay, so if I gave you, let's say 14y plus 21. And I said, factor this expression and give me an equivalent expression. Then you would turn it back into something that looks like something we could distribute. So I see 14 and 21, and I know that 7 is a factor of both of those. So I know that I could factor out a 7. And I know that 14y divided by 7 and I would say that 21 divided by 7. So I would know that 14y divided by 7 would be equal to 2y, and 21 divided by 7 would be equal to positive 3. And I know that I factored out the 7, so I would put that on the outside of my parentheses. So 14y plus 21 would be equivalent to 7 times 2y plus 3. You're just seeing what can I factor out? How can I turn this into something that looks like the distributive property when it's already simplified? Let's try it another one. Let's say we have 9g plus 6 minus 15h. How could I find an equivalent expression that looks like distributive? How can I factor this? Well, I know that 9 and 6 and 15 are all multiples of 3. This is where that number sense has to come in. You have to think about what numbers do they have in common? 3. So I could factor out the 3. So I'm going to put that 9g plus 6 minus 15h is equivalent to, I'm going to factor out 3. So I'm going to put 3 on the outside, put my parentheses, and then I would go back and say 9 divided by 3 would be what? 3g, because it's 9g divided by 3. Then I would say, what is positive 6 divided by 3? Well, that's positive 2. And then I would say, what is negative 15h divided by 3? And that would be negative 5h. So I have worked this backwards. I have factored this expression into a distributive property expression. And if I wanted to go back and check, I could. 3 times 3g is 9g. 3 times positive 2 is positive 6. And 3 times negative 5h is negative 15h. So I know that my answer is correct. Let's try another one. This time let's do 25m plus 30 minus 5n. How could I factor this out? Well, first of all, I have to think, what number do all 3 of these have in common? And I see that they either end with a 5 or a 0, so that means that I can factor out a 5. So I'm going to go ahead and write it over here because I'm making my equivalent expression over here. So 5, and I know I'm going to need parentheses. So I'm going to factor out, what is 25m divided by 5? Well, that's going to be 5m. What is 30 divided by 5? Positive 6. And what is negative 5n divided by 5? That's going to be negative 1n, which means I could also write that as negative n. Either way, it's okay. So this tells me, let me cover this part up, that 25m plus 30 minus 5n is equivalent to 5 times 5m plus 6 minus 1n. So I could go back and check. Is 5 times 5m 25m? Yes. Is 5 times 6 positive 30? Yes. Is 5 times negative 1n negative 5n? Yes. So I know that my answer is correct. Let's try another one. This time let's do 21 minus 42a plus 56b C. Okay? I need to think, what do all three of these have in common? I know that all of these have the factor of 7. So I'm going to factor out 7. So I want to make an equivalent expression. So I'm going to do 7. And I want to come back and say, okay, what is 21 divided by 7? That's going to be 3. What is negative 42a divided by 7? That's going to give me negative 6a. And what is 56c divided by 7? That is positive 8c. So this tells me that these two expressions are equivalent, and I can check them. Is 7 times 3 21? Yes. Is 7 times negative 6a negative 42a? Yes. And is 7 times 8c positive 56c? Yes. So I know my expressions are equivalent. They're equal to each other. They mean the same thing. Let's do one more, and then I will let you try on your own. This time, let's do 18x plus 36 minus 12y plus 6. And I want to make an equivalent expression. So what numbers do I have in common between 6 and 12 and 36 and 18? I know that those are all divisible by 6. So 6 is going to be the factor that I factor out. So I'm going to put a 6 on the outside of my parentheses. So now I'm going to go back. 18x divided by 6 is equal to 3x. 36 divided by 6 is equal to positive 6. Negative 12y divided by 6 is equal to negative 2y. And 6 divided by 6 is equal to positive 1. That's the end of my parentheses. So let's go back and let's see if these are equivalent. 6 times 3x is 18x. 6 times 6 is positive 36. 6 times negative 2y is negative 12y. And 6 times 1 is positive 6. So that tells me that I am correct. So the trick to this is just make sure that you are thinking about what do all these numbers have in common. Now it is going to be much more difficult if you don't know your multiplication facts, and many of you struggle with your multiplication facts, and it just gets harder and harder. So I hope that you are studying your multiplication facts if you have issues with that, and I hope you do well with this activity. So good luck practicing this activity, and next week we will be practicing more of this all week to prepare for our test next Friday. And if I see we're not ready, I'll move the test to the next week, but hopefully we'll be ready by Friday. All right, good luck and have a great day.